Welcome to KP classes. My name is Rukku. In today's video, we'll be discussing how to score full marks from geomorphology. So we know geomorphology is a very important subject in all the competitive exams, whether it is IIT JAM, GATE, UPSC-GSI examination, BARC or any competitive exam of geology, geomorphology is a must. So there are different type of questions that can be asked from geomorphology. There can be numerical questions, match the following, multiple selection questions, multiple choice questions, etc. So here today we will be having an idea about the entire content part. It will be an introduction to geomorphology, important topics to memorize, which are the important subject that you have to keep on understanding to get the full mark, to score full mark from geomorphology subject, equations for numerical question solution, and we'll also solve few PYQs also, previous year questions. So let's first have an idea about the topic geomorphology. So when it comes to geomorphology, we know there are a few textbooks. Summerfield is one of the most important reference textbook that you have to go through while preparing for geomorphology in competitive exams, especially for UPSC exams and NET CSIR paper. Summerfield is a must. The diagrams or tables from Summerfield, they use the same exact images or exact diagrams from Summerfield in the competitive exams. Geomorphology is almost a theoretical topic where we will be discussing about landforms and different geomorphic agents which create these landforms. So the major landform is obviously fluvial. Fluvial landform is very important. The entire fluvial processes are also very important for competitive exams. If I divide the whole geomorphology, we can divide it into endogenic processes and the landforms associated to it, or exogenic processes and the landforms associated to it. Endogenic and exogenic symbol, the processes that take place inside the earth, processes that takes place outside the earth. So because of an earthquake or because of volcanic activity, there are certain type of landforms develop, tectonic activities, etc. create a landform. Other than that, because of the processes such as wind, the running water, stagnant water, glacier, these exogenic processes can also create landform. So this is very important to memorize a particular agent and the landforms associated with it. If it is fluvial, what are the landforms associated with that particular fluvial processes, or if it is glacier, the landforms associated to glacial activity. There is glacial, fluvio-glacial condition, glacial plus marine activity. So combined geomorphic processes and landforms are also important. So you can go through basic textbooks, reference textbooks, or you can also go through our study material in which entire detail wise, point by point topics are provided, like definition of each landform, which is a very common question. Like for example, in UPSC they will ask about till deposit, or what is the difference between till and drift, or what is the difference between different type of delta, like there is hypopycnal delta, homopycnal delta. So what is the difference between these different type of delta deposition? So all these things in detail is given in our textbook. You can refer that too. Now moving forward about the equations from geomorphology. Geomorphology numerical question is a must in GATE examination. Every year there will be at least one numerical question from geomorphology, and geomorphology numericals are one of the easiest numerical question also. So it's very easy to score solve numerical question from geomorphology. It's not very hard, or there is no much equation, there is no much equation to memorize also. These are very conceptual equations. So let's have an idea about all the important equations to solve numericals from geomorphology. The most important equation to memorize is the equations associated with an open channel. For example, what is the wetted perimeter means, what is a discharge, etc. So let's see these equations. First of all, what is a discharge term? There are already previous year questions asked from this section. A discharge in an open channel is equal to the cross-sectional area of the channel multiplied by mean flow velocity. Further, we'll see how to calculate mean flow velocity. So discharge is equal to cross-sectional area of the channel multiplied by the mean flow velocity, or I can also write it as width of the channel into depth of the channel into mean flow velocity. Width into depth provides the average area, cross sectional area. Remember, here we have to use cross sectional area of the channel and the mean flow velocity, or simply with average width of the channel multiplied by average width, depth of the channel into mean flow velocity. Now the next terminology is the wetted perimeter term. Wetted perimeter is the length of the boundary in which water is in contact with the channel. That's what is called as the wetted perimeter. So the equation for wetted perimeter PW will be equal to width of the channel plus 2 into depth of the channel. This is the equation for the wetted perimeter. Wetted perimeter is simply the width of the channel plus width of the open channel plus twice the channel depth. Now another important equation is stream power. Stream power is notated by the letter O. So stream power is defines the amount of energy required for the transportation of bed load. So depending upon the stream power of different channel, the ability to transport bed load also varies. For example, braided channel has high stream power than a meandering channel. Why? Because meandering channel is a suspended load channel, whereas braided channel is mainly a bed load channel. Okay, so I hope you understood what is the variation. Now when it comes to the equation, density of water that is flowing through the river system multiplied by acceleration due to gravity multiplied by the discharge, and at last the channel gradient S. So I forgot to mention over here, discharge is notated by the letter Q. So discharge into density of water into acceleration due to gravity into channel gradient is what gives the stream power, and stream power defines the amount of energy required for the transportation of bed load sediment. Now when it comes to further terminologies, the hydraulic radius of the channel, hydraulic radius R is equal to simply it is the cross sectional area divided by wetted perimeter. The cross sectional area divided by wetted perimeter gives the hydraulic radius of the channel. So these are the equations associated with an open channel, or characteristics of an open channel: discharge, wetted perimeter, stream power and hydraulic radius. So we'll see the rest of the equations. Now over here I have mentioned the mean flow velocity V. How can you calculate mean flow velocity? Mean flow velocity is calculated by two different equations are there: Manning's equation and Chase's equation. Let's see what are those. When it comes to the mean flow velocity terminologies, first one is the Chase's equation. According to Chase's equation, mean flow velocity notated by the letter V is equal to Chase's coefficient C multiplied by root over hydraulic radius R into channel gradient S. So hydraulic radius R into channel gradient S with Chase's factor, Chase's coefficient C gives the equation of mean flow velocity V. According to this is by Chase's equation. Now another terminology is given by Manning's equation, providing the mean flow velocity again. According to Manning's equation, the mean flow velocity is equal to 1 by n, where n is the again roughness coefficient provided by Manning's roughness coefficient. It is an index of the channel bed roughness, actually, that provides us an idea about the friction of the channel bed. Okay, so 1 by n multiplied by the hydraulic radius into 1 by hydraulic radius raised to 2 by 3 hydraulic radius raised to 2 by 3 into channel gradient raised to 1 by 2. This is the equation for the mean flow velocity by Manning's equation. Now going further, the next important one is about the drainage basin morphology. So there are no much numericals asked from Chase's equation part, yeah, Manning's equation part. Usually they ask questions from either from the open channel characteristics or from the channel morphological part. So let's see what is the equations. Those are very common, very easy equation. You guys might know. So just consider this as a revision section, because geomorphology is a very easy subject. Or there will be coming up with similar videos actually for other topics also. Now when it comes to the drainage basin morphometric characteristic, first of all you should know how to number a drainage basin stream network. Like based on the there are two different types of numbering of stream network: stroller method and Shreve method. So we'll be following the stroller, and when you compare with the stroller and Shreve situation, we will be using the stroller method for stream numbering. Simple. If this is a drainage channel, drainage basin with network of river system over here. So if the first order streams will be numbered as the one without any segments joined to them are numbered as first order streams. So these are 1, 2, 3, 4, 5 first order streams are there. 2 first order streams joined together to make a second order stream. 2 second order streams joined together to make a third order stream. When a third order is joined with a first order stream, it will not change any course. It will continue as third order only. So this is the stroller method. Now after understanding the stroller method, we have to calculate the bifurcation ratio. Bifurcation ratio, actually you need to calculate the number of first order stream, number of second order stream, etc. So bifurcation ratio between first order and second order is calculated by this total number of first order stream divided by second order stream. In the same way, you can calculate the bifurcation ratio between second order and third order. Number of second order stream to number of third order stream. Now in few years they will ask to calculate the average bifurcation ratio. Have to calculate average bifurcation ratio. For example, in this system there are 3 first, second and third order streams are there. So bifurcation ratio between first order and second order will be calculated. Bifurcation between second order and third order will be calculated. And for example, if this first value is coming as x, second one is coming as y, so the average bifurcation ratio will be equal to x plus y divided by 2. Simple way of calculating the average. Okay, so this is very common question. Now other than that, the next question is to calculate the drainage density. So I am only discussing important equations over here. There are more equations related to geomorphology. Now when it comes to drainage density, it's calculated by the summation of total length of the streams in a drainage network divided by the total drainage basin area. Total drainage basin area. So the total stream length divided by drainage basin area. This ratio is what we call as a drainage density. So I hope drainage density and bifurcation ratio is clear. There are other terms, relief ratio, ruggedness number, elongation ratio, etc. are also there, but no much questions have come from those terminologies, circularity ratio, etc. Now according to these are major equations for GATE examination. Other than this, there are few terms that you have to look for NET examination also. For example, hypsometric integral part. Hypsometric integral is very important. Have to calculate the hypsometric integral. Numericals or theoretical questions do come from hypsometric integral section of geomorphology in this particular part, or from the terminologies associated with the NET CSIR examination. Now let's solve some previous year questions over here. So the first question, the areas of drainage basin A and B are 25 km square and 50 km square respectively. The length, total length of drainages of all orders in basin A is 20 km. If both the basins have the same drainage density, the total length of drainages of all orders in basin B in kilometer is dash. So it's a very easy question. This is actually 2024 GATE exam paper. It's a very easy question. For there are two different drainage basins are provided over here, drainage basin A and drainage basin B. Drainage basin A and drainage basin B are there. So for drainage basin A, they have provided that the area of drainage basin A is 25 kilometer square and that of B is 50 kilometer square. This is the drainage basin area. Now they have mentioned that the total length of drainages of all order in basin A is, so summation of length is 20 kilometer for A. If both the basins have same drainage density, so we need to calculate the drainage density of both A and B should be the same, and then we need to calculate the total length of drainage basin. So you need to calculate this particular value. So they have provided drainage density is the same. So simple, we know the equation to calculate the drainage density. Drainage density is the total length of the stream divided by the basin area. So here it will be 20 divided by 25, 20 kilometer divided by 25 kilometer square, and 20 by 25 will be equal to 0.8. So and in question they have mentioned that both the drainage basins are same area. So here also it will be equal to 0.8. So we need to calculate this simple term. So here equation for calculating the total length of the stream channel will be equal to using the drainage density equation from here we can simply calculate. So this one will be equal to drainage density multiplied by the area of the basin. So drainage density is 0.8 into 50, right? 0.8 into 50 will be the calculation. So that will be 40 kilometer square. 40 kilometer will be the answer. So simple question. Moving to the next one. This is 2023 GATE question. In a drainage basin, the number of first, second, third, fourth and fifth order streams are 248, 48, 2 and 1 respectively. The average of all calculated bifurcation ratio is dash. That's it's also an easy question. We need to calculate the bifurcation ratio between the first order stream and second order stream. So S1 by S2 is 240 divided by 40, and that of S2 by S3 is equal to 40 divided by 8. S3 by S2 is equal to 2 divided by 8. S4 sorry S3 by S4 is equal to 8 divided by 2. S4 by S5 is equal to 1 divided by 2. So the total number of streams, first order streams are 240, that of second order stream is 40, S2 by S3 is 40 by 8, this is 8 by 2 and this is 1 by 2. So easy to calculate. 240 by 40, 40 will be equal to 6, this will be equal to 5, 4 and 0.5. Okay, sorry I did a mistake. So this will be S5 by S4, that will be 2 by 1, which will be equal to 2. Now we need to calculate the average bifurcation ratio. So for calculating the average bifurcation ratio, just need to calculate the average of all these values. So average will be 6 plus 5 plus 4 plus 2 divided by 4. Easy. 6 plus 5 plus 4 plus 2 by 4, that will be equal to 4.25. Easy question, very easy. Now moving to the next one. The cross section of a river channel is approximated by a trapezium. The river has an average channel width of 40 meter and the average depth of 3 meter. If the average flow speed is 2 meter per second, calculate the discharge. Another very easy question. So we know to calculate discharge is equal to cross sectional area into mean flow velocity. So if they have not provided the cross sectional area, if you know the average channel width and average channel depth, we can calculate it with this equation, width into depth into mean flow velocity. So width is provided here as 40 meter, depth is 3 meter, velocity is 2 meter per second. Simple again, another simplest question. So the answer will be 240 meter cube per second. So these are the basic, these are the type of previous year questions, like these are the type of questions they have asked in GATE examination. In JAM also the questions are very similar. In NET CSIR, in UPSC they don't ask much numerical question. Even if they ask, questions will be similar to this. In NET also the questions are comparatively similar. So if you want to join our KP GATE classes section, if you are a JAM aspirant, there are courses for JAM like online test series available, online live classes are available, recorded lectures and study material section is available. In our study material we have provided in detail, like you don't need to go through, there are different different study materials are available, but different reference textbooks are also available. And geomorphology is a completely theoretical type of part, and there are so many new journals and papers are also there which you have to go through to score a full mark from geomorphology. For even if it is NET or GATE exam, you have to go through these papers also. But in our study material we have referred all these journals required or the reference textbooks required, and we have made a detailed text study material. So even if you are a IIT JAM or CUET aspirant, or you are a GATE Geology aspirant, your NET examination, you are preparing for NET or UPSC-GSI List, you can use our study material, or you can simply, what you can do is go to the browser, web.classplusapp.com is our website, and you can download KP GATE class application. You don't need to go over these details, just download KP GATE class application, and after downloading, search for the course related to GATE Geology. See all the geology related courses, like the online test series is provided for the GATE, CSIR NET and UPSC Geology related. The online test series is there, online live classes are available, CSIR NET and UPSC GSI plus GATE recorded lectures are available. Study material is also provided. This study material you can see, check over here, it's a very detailed study material. I can assure you that each subject study material is very important, and all 10 books that will be delivered to you, all the important subjects. If you are preparing for NET CSIR, oceanography, meteorology, planetary science, all these topics will also be covered over here in this particular study material. Anyway, coming back to the geomorphology section, I hope you have understood the details of geomorphology and the important topics you have to go through, or the major equations. So if you want to know more about geomorphology or the rest of the equations, you can join our classes. You can contact us in the number over here, or you can WhatsApp us in the same number. You can follow us in our Instagram, YouTube and Telegram channels, where we will be updating every day with important posts or quizzes, etc. You can visit us in our website also over here, or simply download KP GATE classes application from your Android or iOS phone. So thank you so much for today's video, watching our video over here, and we'll be updating or uploading similar type of videos for other important subjects. If you have any preference, if you want to understand the important topics or how to score full mark in a particular subject, you can comment that down below. We'll be creating videos according to that also. So consider this as a series, and more further videos will be coming from this particular section, so that you will be able to score complete full marks from each subjects of geology. So thank you so much. This is me Rukku Raju from Knowledge Point. Thank you.